Hey everyone, welcome back. Today we are going to learn about the types of measures of central tendency and their competitions. In this video, we will go beyond the basics and take a deep dive into various types of mean and how to compute them. Specifically, you will learn how to compute arithmetic mean for raw, ungrouped, and grouped data, as well as for geometric mean, harmonic mean, weighted mean, and combined mean. On the course of this discussion, we will try to map which average type is most appropriate to which data type. If you are new for this channel, join our learning community by subscribing and activating the notification bell to stay updated with. Comments and questions are welcome. Stay with me. So let us see how to compute arithmetic mean from raw data. Raw data is unprocessed data or unorganized in the form of tabular representation. So from which, how can we compute arithmetic mean is the question here. We do using this formula. For example, we have a data on family sizes of 7 households, 2, 7, 8, 2, 3, 7, 7. These are nothing but the raw data. Data on family size of 7 households. So what's the question here is how to compute the average family size per household based on this data set. This is nothing but we follow these steps. First, we sum these observations, right? And we obtain this number, 36, which is the total individuals of the 7 households. Is nothing but 36 now. And we do have n is equal to 7 households. To obtain the average family size of 7 households, average family size per household, we compute this 36 by the number of households. Then we come up with this result, right? 5.14. So what we can say about this figure now, the average family size per household is nothing but 5.14, right? These are countings, no unit of measurement. We can say 5.14 individuals, right? How can we compute arithmetic mean from ungrouped data? Ungrouped data which is represented using frequency distribution. Frequency distribution is nothing but the tabular form of data presentation. So from which we can compute arithmetic mean using this formula. Let us see the example. Example, we do have frequency distribution of family size, meaning we represented the above raw data using frequency distribution as follows on 7 households, right? Meaning we do have 2, 3, 7, 8 distinct values in the raw data, and we count how many 2's are there, how many 3's are there in the raw data, how many 7's are there, how many 8's are there. To obtain the average now, the arithmetic mean, shortly, this is 2 times 2, meaning xi times fi on respective rows, right? 2 times 2, 4, 3 times 1, 3, 7 times 3, 21, 8 times 1 is 8. So we obtain this circle element here. This circle element is all about the product of this fi and xi, where I runs from 1 up to 4, right? Because you have 4 distinct values here. So we sum these rows and we obtain 36. Then we divide by 7, the same result. We can compute also arithmetic mean from grouped data. Grouped data is not frequency distribution for continuous variables or continuous data, meaning data grouped into class intervals with midpoints is now useful to compute arithmetic mean using this formula, which is similar to that of ungrouped one, but what the difference is, x is midpoint, but in the ungrouped, x was the distinct values. Let us see one example on data of scores of 100 students in a mathematics exam. How many students are there? 100. If we have this frequency distribution at hand, we know that it is possible to find the central value using computing arithmetic mean from this grouped frequency distribution. So how can we do it? Right? We do have class intervals, 6 class intervals or classes. We do have their respective frequencies from which we compute these midpoints. The third element is now midpoints or class markers, meaning we add the lower class limit and the upper class limit of that class interval and we divide by 2, we come up with the midpoint of that class, right? So this element is nothing but midpoints. So everything is now known. to compute the arithmetic mean from group frequency distribution. Then we multiply 8 by 35, which is 280, 13 by 23, which is 299, this one by this one, right? Then we obtain the fourth element, which consists the product of every i's class. Now I runs from 1 up to 6. So we obtain this sum, and we do have the total number of students. Then we divide this by the number of students, which is 15.75. So what does it mean, this figure? The mean score of the 100 students is approximately 15.75, which lays in the third class interval. The highest frequency is in the first range or the first class, meaning most students score low. As we can see from this frequency distribution, most of the students 35, 23 are. How many students are there? Whose score is from 6 up to 15? This is nothing but 35 plus 23, 58. Above half of the students score in the lower class intervals. There are students who score on the upper class intervals, but these students are few, 9 plus 6, whose score is from 26 up to 35. This distribution suggests a left skewed distribution, right? Where the majority of scores are clustered in the lower intervals. So what you can recommend for educators based on these findings, what you can say, what you can conclude, this may indicate a need for remedial support or curriculum review. This recommendation goes to the concerned body. Let's proceed to the second type of mean, which is weighted mean. Weighted mean is nothing but an average where each data point is multiplied by a predetermined weight based on its importance. So for such data, we compute using this formula. We multiply every i's observation by a's weight, and we divide by the sum of weights. This type of mean is useful for calculating averages for final grades in universities, stock indices, and composite indices in business areas and other sectors. Wow, let us see this example. Student score with different weights. Let's say a student has sit for exam for 5 subjects, right? And he scored this element for each respective courses, right? English 60, biology 75, mathematics, and such forth. But we know that there are predetermined weights for each courses. English is weight 1, biology 2, mathematics is with weight 1, physics 3, chemistry 3. But what the question here is how to compute the average score, right, per course. We follow the formula above. How can we obtain those numerators and denominators in the formula? This is, we multiply xi by wi, 60 by 1, 25 by 2, this one. Then we come up with this fourth element. We sum these numbers, then we obtain this number. Then we divide by 10, which is the sum of the weights. Then at the end of the day, we come up with this weighted mean. What does it mean? What does this figure refers for? The average score of the student per course is 61.5. The third one is combined mean. Combined mean is nothing but the overall mean of 2 or more groups combined together. We do have the mean of 2 or more groups, right? What the interest here is to obtain the mean of means. So we obtain using this combined mean. When to use this combined mean? This is nothing but when we are interested to combine results from different classes, departments, or time periods, right? There is distinction among classes, but those classes are under the same domain. So when we need the mean of each classes, right, we consider the mean of each one. When we need the mean of every individuals, combine these classes in one, we make use of this combined mean. For example, we have 100 students in a class who took an exam out of 100, right? But the students were females and males, right? So before obtaining the aggregate mean or the combined mean, the overall mean of the 100 students, we have the mean of each gender, right? The mean of female, the mean of males. For example, the average score of 30 females was 60. The average score of 70 males was 72. This is gender-wise average score. But what's the interest here is the overall mean, regardless the gender. That figure can be obtained using the combined mean, right? We combined the sample size by the sample size of group and its mean, plus the sample size of the second group and its mean. Then we divide by the total sample size. Then we come up with this 68.4. Now, what was this? 60, the average score of female students. 72, the average score of those 70 males, right? Those males, I mean, right? But this one is the average score of the students regardless the gender, 68.4 per student. Let us see the fourth one, geometric mean. What does it mean, geometric? This is nothing but the nth root of the product of all n values. We compute it using this formula, right? We multiply all observations and we take the nth root. This geometric mean is most appropriate for data from annual investment returns, average growth rates, ratios, and much more, right? For example, let's consider this data on investment returns over consecutive 3 years, right? Where the investment returns as the first year was this 10%, second year 20%, as the third year negative 15%, right? So how can we obtain the average investment returns of all these 3 years? This is nothing but using geometric mean, right? So using this geometric mean, we compute and we come up with this result. But to compute these numbers, which are expressed in terms of percentages, we need to convert these numbers into growth factors without loss of information, right? We need to convert these percentages into their respective growth factors without loss of information. This 10% is now converted into 1.1, this number to 1.2, and this one to the negative into this one, right? Positive is nothing but there was growth. Negative, there was a decrease, right? So the decrease is here 15%, right? When we consider these percentages, we make the base 100. When we normalize this into 1, what the base is 1, right? Any deviation from that one is a change. The change may be up or down. The down change is decreasing investment returns. The change above 1 is the growth, right? So we multiply these three numbers and we take the third root, is nothing but we come up with this result, right? So the average return is 3.9. The annual average investment returns is computed to be 3.9. Had it been computed, this investment returns using arithmetic mean, we would come up with 5%, right? So you can see the difference. 5 minus 3.9 is 1.1. This is highest discrepancy is there. So misleading may be there. Now let us see harmonic mean. Harmonic mean is the reciprocal of the arithmetic mean of the reciprocals of the data, right? Mathematically, we compute this harmonic mean using this formula, n over the sum of the reciprocals of each individuals, right? This is useful to compute average of speed for fixed distance, average of rates, or average of parallel resistance, and much more related. For example, a driver drives 6 km at 6 km per hour and return 6 km at 40 km per hour, right? The distance is the same, but the speed is different now. Driver is now making a trip He has gone and he turned back, right? So what the question here is, what's the average speed to cover this whole distance? It is nothing but we make use of harmonic mean. So we compute by this formula, we come up with this result, 48 km per hour. The average speed to make a trip of 6 km is 48 km per hour. For any positive data set, the means follow this inequality. Harmonic mean is always less than or equals to geometric mean. Geometric mean is less than or equals to arithmetic mean. This relationship is true. Have advantages and disadvantages of arithmetic mean. Arithmetic mean is well defined and it is based on all observations in the data set, right? And arithmetic mean is suitable for further mathematical treatment. Arithmetic mean is stable average, does not greatly affected by sampling fluctuations, and it is easy to calculate and simple to understand. Given that advantages, limitations of arithmetic means are given below. Arithmetic mean is highly affected by outliers or extreme observations, and it cannot be used in the case of open-ended class intervals. Open-ended class intervals, it cannot be determined by the method of inspection, cannot be used, it is obvious, cannot be used when dealing with qualitative characteristics.